Okay, happy short week. Yay. We're gonna do the chain rule this week. So we're gonna learn the chain rule today, and all it will take is you practicing. That's all that chain rule is. It's basically when you're looking at the derivative rules sheet that's in the top of module 4, the chain rule is all the stuff on the right-hand column where they don't just have x's, they have inside functions. So it's not actually a new rule, it's just a way to take a derivative when the inside stuff is not just an x. So your homework's due Friday, and then you'll have 2 quizzes Monday, handwritten quiz 4 and D2L quiz number 5. So this, when I say Edfinity questions here today, really, you could do the entire Edfinity assignment after today's class. We're just gonna do some harder examples on Friday with some more intricate stuff in it. So that's the only difference, okay? Okay, so the chain rule. The chain rule allows you to take derivatives using all the rules we know, the power rule, the trig rules, the exponential and log rules, when the stuff on the inside is not just an x. So when you see things like a whole bunch of stuff raised to the 4th, or the square root of a whole bunch of stuff, you should think about the chain rule. So remember, I told you the derivative can only work on one function at a time. So when you have 2 functions stuck inside each other, 2 functions composed together, what you want to make sure you think about is take the derivative of the outside function, don't touch the inside, leave it alone, and then move on to the inside, okay? So the chain rule looks like derivative of the outside function, f prime. You're not going to change the inside function at all. You're going to keep it as g of x times g prime of x. This is different than the product rule, right? So I want you to think about when you see a function, how will you know to use the product rule and how will you know to use the chain rule? So you want to think about what looks different in the product rule than the chain rule. So when I'm looking at examples like this, what you might notice is there's kind of only one x, right? It has a lot of stuff happening to it. It's squared, it's -5, and then that whole thing gets raised to the 4th. In this second one, there's still just one x. It gets multiplied by 4, it gets subtracted 3, and then it gets taken the square root. But there's still just one x. There's one big function with a lot of layers. That's when you should think about the chain rule. If you have 2 x's multiplied together, then you need the product rule, okay? So when you get x's multiplied together, then you have to say, I need the product rule. But when it's just one x with a whole bunch of stuff done to it, then you think, let's do the chain rule. So unlike when we did the product rule and quotient rule, with the chain rule, I don't do a lot of the writing down what f and g are. We just talk about what do you think the outside function is and what do you think the inside function is, okay? So in this first example, f of x is x squared minus 5 to the 4th. I would say that this x squared minus 5 is my inside function, and raising to the 4th is the outside function. So if I was saying, what is my function f, I would say raising to the 4th. What is my function g? My inside piece is x squared minus 5. So if I'm going to take the derivative of this thing, I'm going to leave that inside function alone. So how do you take the derivative of a whole bunch of stuff raised to the 4th? The power rule, yeah, bring the 4 in front and subtract 1 from the exponent. Don't change that inside stuff. So bring the 4 in front, subtract 1 from the exponent. Don't change what was inside there to begin with. This is still going to be x squared minus 5 times. Now I'm going to do the derivative of that green stuff, okay? Because that's my inside function, my g. So I'm going to times it by the derivative of that. So what's the derivative of that green stuff, x squared minus 5? 2x. Great. So notice on your first pass that inside function, the inside layer doesn't change, it stays the same. So we're never taking two derivatives at a time. We're doing one and then we're doing the next. Okay, if you had to talk about this guy, what would you say the inside function is and what's the outside function? Inside function is 4x minus 3. Yep. X side is the square root. Yeah, the outside is square root. How do we take the derivative of square root something? Make it to the 1/2. Yeah, good. So in this second example, my inside piece is that 4x minus 3, and my outside is the 1/2. So again, it doesn't matter what the inside stuff is, you're going to use this 1/2. So how do you take the derivative of something to the 1/2? Yeah, power rule, 1/2 something to the negative 1/2. Don't change that inside stuff. Times, so notice I didn't change that inside stuff. In this box goes the derivative of the green stuff. 4. Great. If you use the chain rule and you don't need it, it's not going to hurt you, right? If you try to use the chain rule and the inside stuff is just an x, you're just going to put a 1 here at the end. And multiplying by 1 doesn't change anything, right? So what you should do when you're doing your derivative practices is sort of like make the chain rule a familiar piece that you use every time you take a derivative. Always think, do I need the chain rule? Was there an inside function? What's happening here, okay? So just always put it at the top of your head and be like, I'm going to always try to use the chain rule. Okay, here's 2 more functions. These 2 functions are kind of the same, right? And that they're both exponential. Yeah. What would you say the inside and the outside of both of these functions is? The inside of the function is going to be the exponent. Okay, so for both of these functions, the inside is going to be the exponent. The outside is going to be the e to the x stuff. So in both of these functions, the inside stuff is that exponent. That's weird. What's happening? Let's try again. Okay. In both of these functions, the inside is the exponent and the outside is e to something. Okay. How do you take the derivative of e to something? It's just e to the x, right? Derivative of e to the x is just e to the x. But remember, I don't have an x. I have all this green stuff, right? So the derivative of this guy is going to be e to the something. Whatever that something is, don't change that something. Times, what goes in this parentheses? 2, the derivative of that green stuff, 2 minus 6t. Okay, take 2 minutes. I don't think it'll take you 2 minutes. Take 1 minute and try to find the derivative of this guy. E to the sine w. Can you find the derivative of e to the sine w? A derivative of e to the sine w. Give me a thumbs up if you're ready. Okay, 10 more seconds. Okay, derivative of e to something is e to something. Doesn't matter what the something is. Derivative of e to something is e to something. E to the sine w times, inside this parentheses, I need the derivative of sine. All right, what's the derivative of sine? Sine, great. What I want you to be careful about when you're doing this is this sine w is an exponent, cosine is not, right? So when you're entering this into infinity or wherever you're entering it, the sine is an exponent, the cosine is not, okay? Same over here. In this first one, the 2t minus 3t squared is an exponent. The 2 minus 6t is not. Okay. Let's start with this one, natural log cosine x squared. If you were thinking about this one, how many functions do you think there are? Three. There are 3 functions. There's the natural log, there's the cosine, and there's the x squared, right? And they're all stuck inside each other, yeah? I don't need any product rules for this one. They're all stuck inside each other. There's just one x. So I'm gonna have to use the chain rule multiple times, okay? And so, because there's kind of 2 inside functions, there's the cosine and there's the x squared. So the chain rule just keeps extending. You do derivative of the outside times derivative of the inside times derivative of the inside times derivative of the inside until the thing that you're left with just has a derivative of 1. Okay, so you just keep multiplying by the derivative of the inside until what you're left with has a derivative of 1. So when I'm starting, I have this cosine x squared as my inside function. So what's the derivative of natural log of something? 1 over something, right? Whatever the something is. So not always going to be 1 over x, 1 over whatever the something is. Oops. Times. Okay, now I'm trying to take the derivative of cosine. Sometimes when I think about it, I think about covering up the function that I've already done, right? I can't reach that tall, so I have to make it shorter. I can't reach that tall either. So if I'm taking the derivative, I say, I just took the derivative of natural log, and now I have this left. So now I'm going to take the derivative of cosine. What's the derivative of cosine? Negative sine. Okay. What should go inside these parentheses? X squared. Yeah, don't change the inside. Okay. So now I say I did natural log, I did cosine, I've got x squared left. What's the derivative of x squared? 2x. We could simplify if we want to, right? Like we could say g prime of x is negative 2x sine of x squared over cosine x squared. We don't have to though, but we could. Totally fine. Just make sure you have parentheses in the right spot.
Oh, so we do something.
No, you don't have to simplify it. This is just if you want to. But we can even make this like tangent of x squared, right? Negative 2x tangent of x squared. But we don't have to. This answer perfectly acceptable. Yes. The derivative of natural log is 1 over u or 1 over x or 1 over something. Yeah.
Where's the 2x from?
The 2x comes from the derivative of the x squared.
So do you just move the exponent in front of it?
Yeah, because the new exponent is a 1, so I don't need to write it.
Oh, yeah, x.
Yeah, just that power rule.
Oh, that's what you call it. And is negative sine x squared, is that the derivative of cosine?
Uh-huh.
So did you
I use the chain rule. Yep, I use the chain rule 2 times. I use the chain rule because I took the derivative of natural log and got this thing. And then I used it again when I took the derivative of sine, and I still had this inside part. So that's why I have 2 multiplies at the end, because I had to use it multiple times. So you have to keep using the chain rule until the inside stuff is like an easy derivative, basically. Okay, tell me what's different about this last problem than the other ones that we've done. It's a log, and
It's a chain rule, but it's also.
They're all in one
yeah,
area.
it's got a product rule in it. Austin says this has a product rule in it. How did he know that? Because it's 3m times tangent of m, right? The green stuff right here, when you're taking the derivative of this guy, you're gonna need the product rule. Do I need the chain rule? Yeah, because I have a log with inside stuff, right? So I'm still gonna need the chain rule, but I'm gonna need the chain rule and the product rule. When I take the derivative of this green stuff, I'm gonna need to use the product rule. I think we should do that separately. Yeah, let's take the derivative of that green stuff first. So derivative of 3m tangent m. Okay, so when I take the derivative of 3m tangent m, my first function is 3m. My second function is tangent of m. So the derivative of this guy is going to be, product rule says, derivative of the first, 3 times the second, tangent m, plus first, 3m, times the derivative of the second. What's the derivative of tangent? Close. Regular secant, yeah. Secant squared m. So this piece that I just found is the derivative of the inside function, the derivative of the green piece. Okay, so when I do the chain rule, I'm going to multiply by this thing because that's the derivative of that inside green function. Okay, here we go. S prime equals, what's the derivative of log base 6 of something? 1 over x, but not x, 1 over the green stuff, right? 3m tangent of m times, so close. I think it's 1 over natural log of 6, yeah? Okay, so this piece right here, all of this is the derivative of log base 6. All of this stuff is the derivative of log base 6. This ln of 6 part here comes because it's a 6 there and not just an ln. Okay, times, what's going to go in here? Yeah, that product rule thing, this green part right there. Okay, times, I can't fit it. 3 tangent m plus 3m, I can fit it. Secant squared m. So all of these pieces at the front, 1 over 3m tangent m times 1 over natural log of 6, that was all the derivative of log base 6 of something, right? Log base 6 of this guy. This thing in the brackets at the end was the derivative of the inside function using the product rule because it had 2 m's multiplied together. So I needed the product rule to find its derivative. Yes. Just be careful if this has like pluses or minuses in it, put some parentheses. Oh yeah, you can put it right there too. All right, here we go. This guy says cosine squared of y. Why do I have this on the chain rule example? Okay, it's a y not an x, but because it's cosine squared, right? When I write cosine squared of y, I'm sort of abusing notation, yeah? What does it mean to do cosine squared of y? How do you compute the the cosine squared of something. You find the cosine and then you square it, right? So really this guy, cosine squared of y, is cosine of y all squared. Now it's easy to see that the inside function is cosine of y and the outside function is squaring. So that's the one that's going to trick people all the time. When you write cosine squared, you have to think about this is a chain rule. It's really a whole bunch of stuff squared. Okay, so how do I take the derivative of this guy? Power rule, bring the power in front. So 2, leave the inside alone, cosine y. Oh. To the 1 times, what goes in these parentheses? Derivative of cosine, negative sine y. Okay, you try this one, sine of tangent of x. So take a minute. You think, can you do it in a minute? Okay. Try to take the derivative of sine of tangent of x. Remember, there's an outside and an inside, right? Because there's only one x there, so you should be thinking about the chain rule. Take the derivative of sine of tangent of x. Okay, thumbs up if you're ready. Okay, what's the outside function in this case? Sine, yep. And what's the inside function? Tangent of x. Okay, derivative of sine is cosine. Great. Leave the inside alone, right? So still write tangent inside there. Boom. Times, yeah, derivative of tangent is secant squared of x. Good. You guys have it printed, so you know what's next. Oh, I know what's next. Okay. I'll scroll back in a second. Let me just click this link. Look at it, put little coloring up there when I was doing the other one. I don't understand it. Where did that open? Okay, so x to the 7th times 5 plus 8x to the 3rd. You need the chain rule because of that bunch of stuff to the 3rd. And then you need the product rule because you have these two pieces, this guy and this guy. Okay, derivative of x to the 7th. 7x to the 6th times, leave the second function alone. Don't change it at all, right? Plus, leave the first function alone, x to the 7th times the derivative of this guy. Derivative of 5 plus 8x to the third is
3.
3. Bring the power in
Oh, yeah,
front.
5 plus 8x.
5 plus 8x to the second times the derivative of the inside, 8.